Hello, hello, hello. Very good evening, good afternoon, good morning, whenever you are watching this lecture. Now, in today class, I am going to start the chapter, and the name of the chapter is called Haloalkanes and Haloarenes. This chapter is also called Alkyl and Aryl Halide. Now, in this chapter, what are the things I will teach you? Topic to be covered. Topic to be covered. The topics will be: first topic I will complete reactions of haloalkanes. Then second topic I will cover method of preparation of haloalkanes. Then third topic I will cover reaction of haloarenes. Reaction of haloarenes. Then fourth topic I will cover method of preparation of haloarenes. And then fifth topic I will cover physical properties of polyhalogens. Sir. Yes, students, once again, very good afternoon, good morning, good evening, whenever you are seeing this lecture. Today we are going to start one of the very important topic, and the name of the chapter is called Haloalkanes and Haloarenes. Those who have already seen hydrocarbon, electrophilic aromatic substitution and Grignard reagent, for that student this chapter is the most easiest chapter, but something new will come. Don't think each and everything will be like that only. Okay, sir. And in this chapter I am going to cover these topics like reaction of haloalkanes, method of preparation, haloarenes, means reaction and preparation of haloalkanes, and reaction and preparation of haloarenes, then physical properties. Now, in this chapter, basically what happened, do you know? Suppose some Rx will be there. Now, this X will be either fluorine, chlorine, bromine or iodine. We know that fluorine, chlorine, bromine, iodine, electronegativity is more. Electronegativity of X is more than electronegativity of carbon present in the R. Because of that, this will get partial negative, this will get partial positive, because electronegative element attract the electron towards itself. After that, what happen? Some nucleophile will attack over here, and this will convert into RNU. Means in this reaction, what happen? This is also a nucleophile. Fluorine, chlorine, bromine is also a nucleophile. One nucleophile is there. Now there is a possibility that some nucleophile is attacking over here. Some nucleophile is doing substitution. It means in this reaction, what I am trying to say, in this reaction, either there is a addition of nucleophile or there is a substitution of nucleophile or there is a elimination of nucleophile or there is a rearrangement of nucleophile. Means don't get confused, not rearrangement of nucleophile. Simple rearrangement happen, means rearrangement. What I am trying to say, first these are the topic that we are going to cover. Some reaction I have just written random reaction. There is no use of this reaction, just I have written to make you understood that one nucleophile is going, one nucleophile is coming, something happen in this reaction. It may be in this chapter, whatever with the reaction we will study, in that there is a addition happen or substitution happen or elimination happen or rearrangement happen. Substitution I have already dictated you. Remember substitution, in that I have dictated you hydrocarbon first lecture or one shot. What I have dictated? Halogenation. After that nitration. After that sulfonation. After that Reed's reaction. These are the topic I have dictated. Reaction of alkane over there. So that topic already covered. So that I will not cover over here. Understood? So these are the things we have to study, and that I will dictate you. Slowly you will understood what I am trying to dictate. Okay, sir. Now, First of all, before starting this chapter, we have to understood about the solvent. In our chemistry language, there are two types of solvent. First of all, you know what do you mean by solvent? Like water is a solvent. That is solvent. There are two types of solvent. One solvent is known as polar and one solvent is known as non-polar. One solvent is known as polar, one is known as non-polar. Non-polar means, and polar means they didn't have polarity, is non-polar, like CCl4, like alkane, like benzene, like etc. I will write lots of things is there. Means what I am saying, non-polar means what? Whose dipole moment is zero. Dipole moment is zero means what? C, Cl, 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 Cl. The dipole moment going from here to here, here to here. These two gets cancelled. Here to here, here to here. These two gets cancelled. So there is no polarity in these molecules. There is no polarity. No polarity means no del plus, del minus over here. Polarity is there only, then you will get del plus and del minus. Na? If no polarity, no del plus, no del minus. So like that, benzene ring, alkane, CCl4, they are non-polar solvent. Now, polar solvent are of two types. Polar solvent are of two types. Either polar solvent will be protic or polar solvent will be aprotic, or polar solvent will be aprotic. What is polar protic solvent and what is polar aprotic solvent? Protic means what? Proton. Means there is a presence of proton. Means whenever polar protic solvent, na, so what you will see, there is one electronegative atom. There is one electronegative atom. There is one electronegative atom, and if with that electronegative atom hydrogen is attached, with that electronegative atom hydrogen is attached, the electronegative atom will take the electron, and because of taking the electron it will get del minus, it will get del plus. So those elements which has electronegative atom like fluorine, chlorine, bromine, iodine or oxygen or nitrogen, and with that compound if hydrogen is present attached with electronegative atom, that solvent is known as polar protic solvent. Aprotic, A means absence. A means absence. Means there is a substance in which electronegative atom is there, and with that electronegative atom no hydrogen. Hydrogen is not present. So if the electronegative atom contain hydrogen, that are polar protic. Electronegative atom does not contain hydrogen, polar aprotic. Non-polar, where there is no polar compound, no polarity. Del plus, del minus is not created, that is known as non-polar compound. Now, sir, we understood this, but we didn't know how to check. Suppose I will say H2O is there. It is which types of solvent? Second one, I have written ROH is there. Third one, I have written ROR is there. Fourth one, I have written RC double bond O, OH is there. Fifth one, I have written CH3, C double bond O, CH3. Sixth one, I have written HC double bond O, NH2. Now I will ask you, tell me, first one is polar or aprotic or protic? Polar is there, but polar, non-polar we didn't have to study that much. Basically we have to study polar protic and polar aprotic solvent. Acha sir. Now over here I have written some example. Tell me which one is polar protic, which one is polar aprotic. H2O, sir, electronegative atom is oxygen and they have hydrogen, the polar protic solvent. PPS means polar protic solvent. Acha, sir, oxygen is there, with that there is a hydrogen, polar protic solvent. Sir, oxygen over here, this side also not hydrogen, this side also not hydrogen, polar aprotic solvent. Sir, over here oxygen is there, with that oxygen hydrogen is there, polar protic solvent. Sir, this oxygen is there, with that oxygen carbon is attached, no any other compound is attached, polar aprotic solvent, means no hydrogen is attached, and their name is acetone. Which name is important, that I will write. Over here, with nitrogen, there is a hydrogen attached. It means electronegative atom has hydrogen, the polar protic solvent. Understanding what I am trying to do? Everyone, okay. Some more example I am going to write. Seventh one, H C double bond O N M E M E. Acha. Next, eighth one, H3C S double bond O CH3. Next one, P double bond O N M E M E N M E M E N M E M E. Now over here, if I will ask, tell me. Acha, one more I will write. 10th one, last example. H3C C double bond O N M E M E. Now I will ask, tell me, this one polar protic or aprotic? Sir, this oxygen no hydrogen. With carbon hydrogen is there, na? Not with oxygen. Na? This nitrogen no hydrogen. It means this is polar aprotic solvent, and their name is DMF. I am not going to write the full form. If you have to write, you can write dimethyl formamide. Dimethyl formamide. Dimethyl formamide. Again, the here oxygen no hydrogen, sulfur no hydrogen. It is also polar aprotic solvent. Their name is DMSO. Dimethyl sulfo oxide. Dimethyl sulfo oxide. Acha, this oxygen no hydrogen, this nitrogen, this nitrogen, this nitrogen, no hydrogen is there, so this is also polar aprotic solvent. What is the name of this compound? Hampa. Hexamethyl pentaacetate. If you didn't listen properly, then you will search on the Google. Name of this structure is this HMPA. Now over here nitrogen no hydrogen, here oxygen no hydrogen, polar aprotic solvent, and their name is DMA, dimethyl acetamide. Their name is hexamethyl phosphoacetamide, dimethyl acetamide. Understood? And I have dictated you. This will be used in SN2. Leave that. Those who didn't know, if someone new is watching, you will get confused. So I hope you understood, first of all, what are the topic I will cover and what are the reactions we have to study: addition, substitution, elimination. Then solvent are of two types, polar and non-polar. Non-polar means they didn't have polarity. Polar means they have polarity, means HOH. It will break minus plus. This is called polar. Non-polar means no polarity. Acha, polar solvent have two type, protic and aprotic. Electronegative has hydrogen, protic. Electronegative does not have hydrogen, aprotic. Like that, I have written 10 example, and you understood what is polar protic solvent and what is polar aprotic solvent. After that, we have to study another topic, and the name of the topic is called nucleophilicity. Nucleophilicity. What do you mean by nucleophilicity? Nucleophilicity means the power of nucleophile to attack faster. Nucleophile which attack faster. Means suppose chlorine is also there, bromine is also there. This is also nucleophile, this is also nucleophile. But which nucleophile has more nucleophilicity? Means which can attack very fastly. That is called nucleophilicity. So we are going to see nucleophilicity. Last part I will dictate you what is the short tricks to understand nucleophilicity. But first I will give you logic. Suppose I have taken sodium and some nucleophile I have taken like fluorine, chlorine, F minus, Cl minus, Br minus and I minus. I am asking ki with sodium and fluorine, chlorine, bromine, iodine, if I have taken polar aprotic solvent, tell me which will attack very faster. So you are saying polar aprotic solvent means electronegative atom has R and R, no hydrogen. Electronegative atom has something different but not hydrogen. So R I have taken. Electronegative atom has R and R. Now what happens over here? fluorine is there, sodium is there, plus electronegative has what? R is there, so it has del minus, del minus, del minus, del minus. Understood the point? Understood the point very properly. Don't get confused. Sir. Up to now, any doubt? Polar protic, polar aprotic? No, sir. Only this topic I have taught. Reacts polar protic. This too I have dictated. What are the topic we have to study? Polar protic, polar aprotic, non-polar, no problem. Nucleophilicity means the power of a nucleophile to attack faster. Which nucleophile will attack very fastly? Suppose I am going to take one example. In that example, I have said, suppose I have taken a solvent. Inside that solvent, I have taken polar aprotic. In that solvent, I will put sodium also and fluorine, chlorine, bromine, iodine also. So what happened? Polar aprotic solvent has electronegative atom, no hydrogen. The sodium will be there in the middle. What happened? These all will try to attract towards themselves and make a cage-like structure. But fluorine, chlorine, bromine and iodine, these all are free. These all are free to move. No one is touching them. So what happened? Which one is more stable or which has more bigger size? They will do best nucleophilicity. Means not like that. Again. I am saying, suppose I have taken polar aprotic solvent in a container, and in that polar aprotic solvent like this, polar aprotic, any solvent I have taken, and in that solvent I have put sodium Na+, and I will put fluorine, chlorine, bromine, iodine, line by line, step by step. First I have put fluorine. I am checking it will take 10 seconds to attack. Chlorine, it is taking 8 seconds to attack. So which has no more nucleophilicity? Chlorine. Acha sir. That understood. Means, suppose I will put, what happened? Wherever I will put sodium, everything is attacking on that. And electronegative atom will make a cage-like structure with sodium. Once it will make a cage-like structure, fluorine, chlorine, bromine, iodine is free. Which one is more stable? If I will ask, more stability, we will say, sir, we know that stability is directly proportional to size and directly proportional to electronegativity also. But priority is given to size. Means negative charge stability is directly proportional to size and directly proportional to electronegativity. But first priority in size and electronegativity is given to size. So iodine has more size. So I minus is more stable. Then Br minus. Then Cl minus. Then F minus. It means which is stable. They cannot give the electron easily. It means which can give electron easily? Fluorine, that is less stable. So nucleophilicity of fluorine is more, then chlorine, then bromine, and then iodine. So this is the nucleophilicity of fluorine, chlorine, bromine and iodine. Understood the logic? But instead of polar aprotic solvent, I have taken polar protic solvent. A polar protic solvent, once I will take, what happened? Over here, electronegative atom, it has hydrogen, electronegative atom, hydrogen, electronegative atom, hydrogen, electronegative atom, hydrogen. Sodium I will put inside the middle. What happened? Electronegative atom attract the sodium towards themselves. But as well as it is getting del minus, so it is getting del plus. Del minus to del plus. At the same time, hydrogen del plus will capture electronegative atom. Means previously I minus, F minus, Cl minus is free to move. But this time, because of polar protic solvent, they are also not free. They are also inside the cage-like structure, sir. They are also inside the cage-like structure. Suppose you have taken F minus. On this H, negative charge, positive charge coming due to electronegativity. So they will capture this. Once they will capture this, so what happens? Sir, both are captured. So which one is bigger in size? They can easily give electron. Nucleophilicity of I minus, Br minus, Cl minus, then F minus. Means whenever polar aprotic solvent, smaller is the size, more is the nucleophilicity. Polar protic solvent, bigger is the size, bigger is the nucleophilicity. Sir, we understood, but little bit confusion. I am trying to dictate this part for those students who wants to make their organic chemistry very good. But I am going to give some Prabhatian logic, short tricks. Whenever I will write short tricks, I will write Prabhatian logics. Prabhatian logic is indirectly short tricks. What is the short tricks to understand this? Sir, means suppose you will go from left to right in a periodic table and you will go from top to bottom in a periodic table. Whenever you will go from left to right in a periodic table, left to right in periodic table, here top to bottom in periodic table, then what you have to check, you have to say कि base power and nucleophilicity power left to right decreases. Nucleophilicity power and base power both decreases left to right, either polar protic solvent or polar aprotic solvent. Anything, it is decreases. Suppose I will say hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Which has more nucleophilicity? Sir, carbon, then nitrogen, then oxygen, then fluorine. Nucleophilicity means negative charge is there. So which has more nucleophilicity? Carbon, then nitrogen, then oxygen, then fluorine. Because left to right base power and nucleophilicity power is decreases. So which is decreases, so carbon has more than a nitrogen, then oxygen, then fluorine. Either it is polar protic or it is polar aprotic, and logically you will say कि less electronegative atom has negative charge, unstable, it will give electronegativity increases. Why this will happen? Because whenever you will go left to right in a periodic table, electronegativity increases. Electronegativity increases, negative charge stable, negative stable. Stable means less nucleophilicity, means either basic nature or nucleophilicity nature, either polar protic or polar aprotic. Left to right in a periodic table, it is always decreases, but top to bottom in a periodic table, nucleophilicity and base will decrease and nucleophilicity will increase if polar protic solvent is there. If polar protic solvent, then base power decreases but nucleophilicity power increases. If base is there, means if polar protic solvent is there, then base power decreases top to bottom, nucleophilicity power increases, and nucleophilicity power also decreases when polar aprotic solvent is there. Suppose I have given OH and SH and polar protic solvent. What you will say? O say tipo, left to top to bottom, it will come down. Polar protic solvent increases, means SH has more than OH. But same OH, SH and polar aprotic solvent, अच्छा, top to bottom it is decreasing by polar aprotic. For polar protic increasing but polar aprotic decreasing. So OH has more than SH. And this is the short tricks logic from your favorite sir, Prabhat sir. Sir, we are not calling you my favorite sir. You yourself giving the logic. Trying this, and if you not respect yourself, how other will respect? Okay, sir, we understood. You are a self-obsessed person. Now, so I hope polar protic solvent, polar aprotic solvent, and nucleophilicity everyone has understood. No confusion, without any doubt. Understood everyone? Sure short. Yes, sir, understood. Now, come to the next part of the topic. Now, in this chapter, we have to study the next part of the topic, and the name of the topic is called nucleophilic substitution reaction. Nucleophilic substitution reaction is the next topic we will start. Now, in nucleophilic substitution reaction, we have to study lots of things like SN1, like SN2, like SNI, like SN1 prime, like SN2 prime, like SNI prime, like SNNGP, like SNAE, like SN2 aromatic, like SN1 aromatic. Like that, these many topic we have to study. In that, this SN, one more topic we have to study, SNEA. I have not written because this topic is not in JEE and NEET, neither in mains nor in advance. So I have not written SNEA. The topic name is SNEA. I have not written because it is not in our syllabus. So these many topics we have to study. Over here, the name of this topic is unimolecular nucleophilic substitution, bimolecular nucleophilic substitution, intramolecular nucleophilic substitution, unimolecular nucleophilic prime, SN2 prime, SNI prime, SNNGP, SNAE, SNAR, SN1AR, aromaticity. Now, these many nucleophilic substitution we have to study, but the good part is that these two, if you understood, then remaining are one line solution. These two we have to study in detail. Remaining one line I will dictate with reaction, and you are able to understood these points. I hope you understood how many topics we have to study in nucleophilic substitution reaction. First topic I am going to start is called SN2, then SN1. Like that I will dictate you, and I hope up to now everyone is getting everything. One request, please revise it very properly. One time not coming, see two times, still not coming, then my mobile number 9267937718, where you can message, no calling, and any doubt you can ask. Okay sirs, now we are going to start SN2. SN2, if we will see over here, SN2 mechanism. It is known as bimolecular nucleophilic substitution reaction. Bimolecular nucleophilic substitution reaction. Now, SN2, what happened? Suppose over here C, over here H, over here on the wedge position there is another H, on the dash position there is another H, and over here X is there. Some nucleophile has to attack. Some nucleophile has to attack. What happened? This nucleophile will attack from the back side, inversion side. I will tell you how. Means this X will go outside from here, and this hydrogen will come this side, means this dash hydrogen will come this side, wedge hydrogen will be here, H will be here, and this nucleophile will attack here. Means if you will check what is the transition state. Acha, but what is transition state, sir? I have told you, one student is going from school to college without going any place. Directly school to college is known as transition state, and someone is going from school to college with going for other point, that is known as intermediate, and intermediate are carbocation. Intermediate are carbocation, free radical, carboanion. So over here, without going to any intermediate, directly it will go from house to college. So transition state. In their transition state, what happened? Carbon has 3 hydrogen. Check 1, 2, 3 hydrogen. So what it will do? 3 hydrogen will be like this, like this, like this, and like this. Now in this situation there is a p orbital. From this p orbital, from this side X is leaving and nucleophile is attacking. Means everything happens in only one step. Means don't get confused. That much not a big deal. Again, just wait. First of all, you understood what do you mean by polar protic and polar aprotic solvent. After that, you understood what do you mean by nucleophilicity. After understanding nucleophilicity, I have dictated you nucleophilic substitution reaction. In nucleophilic substitution reaction, First topic is SN2 bimolecular nucleophilic substitution reaction. In this part, this is the transition state. In this transition state, X is leaving and nucleophile is attacking. So nucleophile will always attack from the back side. So it will always form a inversion product. Which product it will form? Inversion product. What happened? X is going outside, nucleophile is attacking from the back side. Now, some important point we have to know. First important point, SN2. First important point is that this reaction is known as Walden inversion, because product is forming inversion product. So it is known as Walden inversion. Second important point, that this reaction is bimolecular. Bimolecular means rate of reaction is directly proportional to alkyl halide to the power 1 and nucleophile to the power 1. SN1 nucleophile to the power 0. So if you will double the alkyl halide, rate will be double. If you double both alkyl halide and nucleophile, rate will become 4 times. Understood? Third important point, कि it is one step reaction. This reaction is happens in only one step, transition state. Fourth important point, कि it is forming R, rectus may be S. Rectus is converted into sinister. D may be L. Dextro may be converted into LIBO. D means dextro, L means LIBO. R means rectus, S means sinister. Why I am dictating all this part where I have dictated GOC? You know that. Acha, haan, sir. We have already studied GOC and isomerism, no need to say. Now, if I will find the hybridization of this species, what I will say? 1 sigma bond, 2 sigma bond, 3 sigma bond. 3 sigma bond plus 0 lone pair. Yani 3. 3 means sp2 hybridized. These two are not taking part in hybridization. Na? One is going, one is coming. Hybridization means which is present. It means we will write fifth point, ki sp2 transition state. Transition state is sp2. Acha. The transition state is highly unstable. Transition state is highly unstable due to how many electron it has? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electron. Means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electron. It has total 10 electron. Yani SN2 will be an inversion product. It has only one step, bimolecular, Walden inversion. It depends upon alkyl halide as well as nucleophile. R may be S, D may be L, or R may be R, not converted also. sp2 is the transition state. Transition state is highly unstable due to 10 electron. And seventh important point, that is very, very, very important point, कि electron withdrawing group will increase the rate. It means if they will ask which one of the following will do SN2 very fastly, you will have to check first electron withdrawing group, second 1 degree, third 2 degree, fourth 3 degree. It means if electron withdrawing group, that will be the most stable or most fastly the SN2 will happen. If electron is not there, electron withdrawing group, then 1 degree, then 2 degree, then 3 degree, because their rate is inversely proportional to steric hindrance. Steric hindrance means crowding. Why it is inversely proportional? Because someone has to attack from the back side. And if already lots of things are there, instead of hydrogen, CH3, 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 lots of things are there, so nucleophile will not easily attack from the back side. Understood the point? Means overall what is happening? There is a nucleophile. That nucleophile, and over here we have alkyl compound 1, 2, 3, and over here we have some leaving group. Instead of hydrogen or something, I am drawing like an atom. There is a leaving group. What will happen? This leaving group is going from here, and this nucleophile is attacking on the back here. This nucleophile is attacking from the back here on this atom. What will happen? O, over here one atom, over here one atom, over here one atom. Nucleophile is coming from this side. At the same time, leaving group is leaving from this time, and after some time Ringa nucleophile will attack over here. 1 atom, 2 atom, 3 atom plus leaving group is going outside. This is SN2. Now in SN2 again first important point I have written Walden inversion, then bimolecular, then one step, then R may be S or D may be L. sp2 transition state is highly unstable due to 10 electron. An electron withdrawing group will increase the rate. The electron withdrawing group more than 1 degree, then 2 degree, steric hindrance, and this I have dictated you. Now I am going to write the stereochemistry or factors on which SN2 depends. Factors. Here what I have written, here I have written the important points, what is happening inside it. Over here on which factor the SN2 will depend. So first it will depends upon high concentration of nucleophile. More is the nucleophile, more concentration is the nucleophile, that much fastly it will attack. Second one, those who wants to attack very fastly, their nucleophilicity must be good. Nucleophilicity must be good. Third important point, steric hindrance less, yani hindrance must be less. Hindrance must be less means 1 degree alkyl halide will do more, then 2 degree alkyl halide, then 3 degree alkyl halide. Fourth important point, कि leaving group must be good. Leaving group must be good. Means R alkyl will be very good, iodide, then bromide, then chloride, then fluoride. Iodide, bromide, chloride and fluoride is a very good leaving group. And fifth important point, electron withdrawing group increases the rate. And this is all about SN2. I will suggest you all see once again if you have any confusion. Understood? Okay sir, I will see it. Now see 1 or 2 times. Points are very important. Now first question, suppose I have written कि we have pH C double bond O CH2 Cl. Second CH3 Cl. Suppose this is A, this is B. Then third one CH3 CH2 Cl. Fourth one CH3 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 Cl. This is C, this is D. What you will say? Sir, over here we have electron withdrawing group. SN2 rate asking. Which has more SN2 rate. So what you will say? A will be electron withdrawing group more. Then it is 1 degree. It is all, see na, over here plus I effect. Electron donating group. Over here electron donating group. Over here 3 side electron donating group. So I have told you कि electron donating group is not good for SN2 electron withdrawing group. So this is electron withdrawing group. In electron donating group, less here, little bit more here, very high here. So A, then B, then C, then D. AB, CD has more SN2 rate. Understanding the point? Second question, suppose I have written, and the question is pH CH2 Cl, CH3 CH2 Cl and Ringa Chinga Pinga Cl. This structure I have written in this part. You will say, sir, that this phenyl is a electron withdrawing group. This alkyl is a alkene is a electron withdrawing group. This is electron donating group. Sir, electron donating group is not good. A, B, C. So B will be in the last. Now we have to judge from A and C. What you will say? Sir, A will be more because whenever I have dictated you in GOC, the minus I effect, phenyl is more powerful. Why? Because phenyl has 3 double bond and it has only 1 double bond. So 3 double bond has more electron withdrawing group than 1 double bond. 3 double bond is more electron withdrawing group than 3 double bond. Na? So 1 double bond, 3 double bond. So A will be more, then C, then B. Suppose I have taken the third question, CH3Cl, CH3Br, CH3I, CH3F. Now over here, sir, it is also 1 degree, 1 degree, 1 degree, 1 degree. So with this, so we are not able to judge. So we will judge according to living group. And which one is following the good living group? Iodine, then bromine, then chlorine, then fluorine. This is A, this is B, this is C, this is D, and good living group is required. Good living group is required. So SN2, good living group is C first, then B, then A, then D, SN2. Suppose I have taken fourth example like this, कि we have NaOH, we have NaOH, we have NaOH, or NaSH, take one NaSH, suppose. Now I will say कि it is 1 molarity, it is 2 molarity, and it is also 2 molarity. So first you will say high concentration of nucleophile is required. So over here, which has high concentration? This and this. Now in these two parts, suppose this is P, this is Q, this is R. In the SN2 we are using polar aprotic solvent. Polar aprotic solvent. And whenever you will go down polar aprotic solvent, then nucleophilicity increases. Nucleophilicity increases for polar aprotic solvent. That only dictated. Nah, sir, don't get confused. No, not confusing. Short trick dictated. Nah, over here. The polar aprotic solvent nucleophilicity decreases. Decreases, not increases. Achha, leave that part. Don't get confused over here. Now, this leave. Up to this understood? Sir, understood. Now check. Over here, they are asking which has more SN2 rate. What you will say? Ki sir, Na plus, OH minus, SH minus. Now, nucleophilicity, which one is less electronegative? Sir, S is less electronegative. It will give easily electron. Concentration to there, but R will give more, then Q, then P. Understood the point? Because both are 2 molarity, high concentration in that. It is less electronegative, so R will be more, then Q, then P. So I hope you understood about SN2. And again I am saying, any confusion you can ask me, don't get nervous. 42 minutes, okay. Now I am going to dictate you the next part of the topic, that is called SN1. And it's a humble request to everyone, any confusion, 2 times I am giving the number, because over there all nucleophilicity will study, and you will get any place confusion, ask me frankly, don't get confused. And if no confusion, okay, enjoy it. Okay sir, okay. Now we are going to see the next part of the topic, that is called SN1 mechanism. SN1 mechanism is known as unimolecular nucleophilic substitution. Unimolecular nucleophilic substitution. In unimolecular nucleophilic substitution, what happen over here, whenever we are doing SN2, so over here we have taken nucleophile, that nucleophile will attack. But now in SN1, once you will see definitely everything very properly, sir. I didn't know I am able to make you properly understood or not, but I hope up to now you are enjoying. So this lecture also you will enjoy. I am dictating 1 time, 2 to 3 times one thing. Over here you will use polar protic solvent. Over here what you will use? Polar protic solvent. What are the polar protic solvent? Like H2O, like TBuOH, anything that has H. Electronegative atom has hydrogen. Just now written, na? So don't get confused. The electronegative has, I am writing this example, but you can make lots of example. Only electronegative atom, fluorine, chlorine, bromine, iodine, SH, oxygen, nitrogen, like that, they are polar protic solvent. Polar protic solvent has dielectric constant. What it has? Dielectric constant. What is dielectric constant? You already know in the chem physics part. Now, what happened in the case of polar protic solvent? I have already dictated now what is polar protic solvent. First, this bond will break. And after breaking the bond, you will get C plus, over here CH3, over here CH3, over here CH3. In the first part, you are not getting intermediate SN2, you are getting transition state, but plus X minus. But over here you are getting intermediate also. Then what happened? Some nucleophile is coming, and that nucleophile is attacking on the positive charge, and you will get C, CS3, 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 and over here some nucleophile is attacking plus X minus. So this is SN1. This is SN1. What is the formation? Intermediate is carbocation, and this step is known as rate determining step because it is the slowest step. It is the slowest step, so it is known as rate determining step. Over here, some important point you will write. The first point you will write कि rate of reaction is directly proportional to stability of carbocation. Rate of reaction is directly proportional to stability of carbocation because intermediate formed is carbocation. In SN2, electron withdrawing group will increase the rate, but in SN1, electron donating group will increase the rate. So that part you have to remind in the mind because sometimes they will ask which of the following will do SN1, which of the following will do SN2, like that. Next important point, that leaving group, same leaving group rate will be good, like iodine, then bromine, then chlorine, then fluorine. Leaving group needed to be good. Now suppose I will write one question on this basis कि रिंगा चिंगा हेयर सीएल, रिंगा चिंगा हिंगा हेयर सीएल, रिंगा चिंगा हिंगा पतिंगा हेयर सीएल, रिंगा चिंगा पिंगा हेयर सीएल हेयर. Now check over here. What I have written? Rate is directly proportional to stability of carbocation. Here carbocation, here carbocation, here carbocation, here carbocation. This is suppose P, this is Q, this is R, this is S. SN1 asking, what you will say? P is 3 degree carbocation, so P. Then this is 2 degree and this is also 2 degree. But this 2 degree and this 2 degree. Plus coming over here, here 3 degree. Here 2 degree. Now, in this side, only one side electron donating group is there. Only one side electron donating group is there. But here, this side also electron donating group. So P then Q. After that, S then R because R is only 1 degree. So over here 2 degree, but only one side electron donating group to 2 degree. But over here on the 2 degree, 2 side electron donating group. So P then Q then S then R. Understood? The electron donating group you have to check very properly. Next important point, that you will say how many important point? Third I have written leaving group, electron donating group, rate directly proportional to stability. Next important point, कि when degree is same, just now see na, when degree is same, then check branching, and rate is directly proportional to branching. Rate is directly proportional to branching. I hope you all would understood. No, something wrong I have said. Don't see like this. Don't get confused. Again. First, rate is directly proportional to stability of carbocation. Electron donating group will increase the rate. Leaving group will be good. Over here, sir, don't see plus I effect. This question, don't, everything is correct. But over here I have said something wrong. What is wrong I have said? Again see this question. Answer is correct. But again see this question. One more question I will take. Here the question is something like this. Ringa chinga hair CL. Ringa chinga pinga hair CL. Ringa chinga pinga hair CL. Ringa chinga pinga CL and this. Now over here, this carbocation, this carbocation, this carbocation, this carbocation. Over here, this carbocation is 3 degree. So without any doubt, because electron donating group as well as in SN1 3 degree more than, first of all, electron donating group, then 3 degree, then 2 degree, then 1 degree, opposite to SN2. 3 degree, this is 2 degree, this is 1 degree, this is also 1 degree. So 3 degree will be more, P. Then after that, Q, P, Q, R, S. So first P, then after that Q. Okay, sir. Then in R and S, when degree is same, then check branching and rate is directly proportional to branching. When degree is same, then check branching and rate is directly proportional to branching. Over here 1 degree, over here 1 degree, but it has branching more, it has less branching, so S, then it will be R. Understood? Acha sir. One more example you have said I will take. Suppose I will take one more example. This. कभी 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 hair Cl, कभी 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 hair Cl. Now in this part, one, it will go 1 degree, it will go here like this, no, not like this, here Cl. Now in this part it will go 1 degree plus, it will go 1 degree plus. This 1 degree A, this is also 1 degree. Which has more? B has more than A. Now understanding what I am trying to say? Or still confused? No sir. Now understand. Now some more example. Suppose I will take another question. कभी 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 Cl, कभी 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 कभी. Over here this Cl will go, plus will come. Over here, suppose I will put Cl here, this Cl will go plus here. Now check, you will say sir, it has 9 alpha hydrogen, it has 0 alpha hydrogen. Suppose this is P, this is Q. Don't judge according to alpha hydrogen, judge according to branching. Q will be more than P. Don't say कि P will be more than Q according to alpha hydrogen. Understood na? Means you have always have to judge according to more branching, according to more branching. Don't judge according to alpha hydrogen. If branching is there, judge according to branching. Don't judge according to alpha hydrogen. More is the written directly कि when degree is same, then check branching. Not written alpha hydrogen for SN1. If not, if they will ask which of the following is more stable carbocation, then you will say that. But SN1 has this. If they will ask which of the following is more stable carbocation, then you will say this and this. Then you will say again Q is more than P, because SN1 will don't get confused. More stable carbocation, P is more than Q. But which of the following will do more SN1? The Q is more than P. Understood? Branching will help. Acha, one more. Suppose over here ringa, chinga, pinga, hinga, linga, patinga, hatinga, satinga. See, one thing I am saying 2 to 3 times, but last time what I am saying, that is correct. Ha sir, we understood it. Now over here it will go, it is coming what? 2 degree plus here coming, leave 2 degree, 1 degree, plus here coming, other color, plus here coming, going, plus here coming, going, plus here coming. This is 3 degree, this is 2 degree. Now over here, it is 2 degree, but resonance stabilized. It is resonance stabilized. The P, Q, R. You will say P will be more, then Q, then R. Over here 9 alpha hydrogen, over here 6 alpha hydrogen. Understood or not understood? Everyone? Yes sir, understood, understood, understood. Now come to the next part of the question. Everyone, C once, 1 time not getting, C 2 times, 2 times not getting, C 3 times. Over here lecture is there, but in the video lecture also I am trying to dictate very good. Now if SN1 asking and SN2 asking any place, and they have given the compound like this, tinga, 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 Cl, or they have given the compound like this, tinga, or they have given the compound like this, Phatinga. They have given the compound like this. 3 compounds they have given. What you will say? Ki these types of compound never ever, kabhi nahi, nahi nahi, abhi nahi, kabhi nahi, never do nucleophilic substitution reaction. Never do nucleophilic substitution reaction. Nor SN1 nor SN2. Neither SN1 nor SN2. Nothing it will do. Not SN1, not SN2. Why, sir? Why this cola D? This cola D is because it has some partial double bond due to resonance. It has also some partial double bond due to resonance. And this is a bridge carbon. This is a bridge carbon. This is a bridge. And according to Breed's rule, sp2 on bridge, not possible. If you remove this halogen over here, this compound is stable, but if you will remove this, what you will get? Ringa chinga plus. And if you find the hybridization over here, you will get sp2. And sp2 hybridization planar is not possible, and that I have already dictated in GOC in the class. Those who are not present in the class, I will dictate you in the lecture also. GOC also I have started parallelly. So SN1, SN2 will never happens with aryl, never happens with vinyl. Vinylic it is, because this will go plus, will come plus on double bond, not possible. Aryl, vinyl and bridge, never ever possible. Understood? Sir. One more important point you will write. Suppose this is neo, na? This is neo. So SN1 is possible, but SN2, na. Abhi nahi. Why? Due to steric hindrance. If someone will say, sir, over here I will remove, it will come plus 1 degree plus, it will do, na. Steric hindrance is there, so SN2 is not possible, but SN1 is possible, because SN1 is do rearrangement, carbocation rearrangement in hydrocarbon. I have dictated you. Understanding what bakbas I am trying to do? 100%, sir. Sir, that is not a big deal. I understood it very easily. Okay, sir. So now some more questions I have to do. It is already 57 minutes. I will do that questions. After that, I will dictate you the remaining portion of the topic. I don't want to disturb you too much, because this chapter I want to cover it in at least 2 lecture, not 1 lecture. And after that, I will compile this also to make 1 shot. So up to now, okay. Bye. Have a nice evening. Enjoy. Take care. Stay home. Stay safe.